Hello friends, so today we're going to discuss the first 4 problems from the latest AtCoder beginner contest 142. So the first 4 problems are relatively simple, but we're going to discuss all of them one by one. The fifth problem is based on bit mask using DP, like bit mask and DP. So I will make a separate video for it. So stay tuned for both of these videos. So let's start. The first problem is given an integer n, Takahashi choose an integer a from the positive integers not greater than n with equal probability. Find the probability that a is odd. So like you are given some n integers from 1 till n, and you have chosen, like you have taken all the numbers. Now you have to find out that if you take out some number, what is the probability that the number is odd. So because you have numbers from 1 till n, you can count out how many numbers you have, and you can also count out how many numbers are there which are odd between 1 till n. Because n is small, you can just directly brute force count out how many numbers are odd, then total number of odd numbers divided by total number of numbers you have till n is equal to the probability of the occurrence of odd numbers. So that's a very simple problem. I like don't need to show the code, but you just have to count out the odd numbers upon the total number of numbers you are given, which is n. Okay, second question is also very simple, in which you are given that there are n friends. They want to ride a roller coaster ride, but they must be at least k centimeter tall. You have the height of the all persons are given to you, so you have to tell how many, whichever person can travel the roller coaster. So because you are given the height of every person, you can find out the height, whether the height of this person is greater than or equal to k. Then you can find out, okay, if it is fine, then print out yes, or count out how many friends have the height at least equal to k, then you can print out that answer. Okay, C question is little bit good, but not that, the intuition can come very fast, in which Takahashi is a teacher responsible for a class of n students. The students have distinct roll numbers from 1 till n. So there are n students, and every student has some roll number between 1 till n. And now every student enter at some different time in the class. So let's assume that the first children enter first, and the third children enter second, and so on. Now whenever the ith children entered the class, whenever he entered the class, after entering the class, he can count out how many total number of children are present in the class at that point, including the student I. So which means that, let's assume he has a class, and he sees the fifth person, the roll number with 5, enter the class. So he can count out how many total number of children are there in the class, which is 1. Then the fourth person enter the class, or let's assume the third person enter the class. So the third person sees that, okay, now there are 2 persons in the class. Then the first person enter the class, he will tell that, okay, 3 persons are in the class. So we are given that for every person, whenever the ith person enter the class, how many persons are there. So let's assume you have an array of size 5. Let's assume 1, 2, 3, 4, 5. When the fifth person enter the class, how many children are there in the starting? 1. When third person enter the class, there are 2 children. First person enter the class, let's assume there are 3 children. Then the fourth person enter the class, there are and the second person enter the class, there are 4 children, and the fourth person enter the class, there are 5 children. Now you are given this sequence, and you have to find out the order in which every children enter. So now, as you can easily see, whenever you see 1, which means that this person, fifth person, enter class first, obviously, because whenever this person enters, there is only one child, which is this person only, fifth. When the second person enter, wherever you found out 2, that's the person which enter second. Whenever you find out third, that person enter third, and so on. So this is also a very simple code. You are given this number, and you have to find out. So you can do it in a number of ways. You can make a pair of every number with the index and sort them out according to this, and then print out the index. Or what you can also do, you can make another vector, and as you can see, the first person. So what you can do, whenever you move from left to right, you are given some index. So you are telling that the first person entered at this point. So you are making a buffer array, in which at the second position put 1, at the third position put 2, at the first position put 3, and then print out that array. Okay, so that's also a very simple problem, in which you can just, I have told you the intuition how to solve this problem, so you can just easily code it out. Now the fourth problem is good problem, in which you are given two positive integers a and b. Let us choose some number of positive common divisors of a and b. So you have to first find out some common divisors, which means the numbers which divide both a and b. Okay, so you are given some number a and b. You have to first find out all the numbers which divides both a and b. And now here any two numbers are called co-prime, which means that if you take any two numbers from all of these numbers you have accumulated, they must be pairwise co-prime. So you have to find out the maximum number of set you can choose such that all the numbers are pairwise co-prime and they are the divisors of a and b. So if it sounds difficult to you to understand, I will draw out some example to make it more clear. Let's take out this example, 12 and 18. So this is 12, this is 18. You have to first find out the numbers which divide both 12 and 18. So what you can see, first find out the divisors of 12. This is 1, 2, 3, 4, 6 and 12. Then the divisors for 18 are 1, 2, 3. Okay, there must be 6 also, yeah. Then there are 6. Then I think so it is 18. There is also 9 and so on. So as you can see, the common numbers are 1, 2, 3, 1, 2, 3, then 6, 6, and that's it. So actually what you can see that the GCD of both of these numbers is 6. GCD means that the maximum divisor of both of these numbers which divide both of these numbers is 6. Then you can easily find out the factors of this number, because the factor of this number will also divide both of these numbers, because if these numbers are divided by its GCD, then the factors of the GCD will also divide these two numbers. So you can easily count out the GCD using the built-in function of GCD, or you can use Euclidean GCD formula to find out the GCD of both of these numbers. Then after finding out the GCD of these numbers, you will find out the factors of the GCD numbers. So let's assume that the factors of 6 is 1, 2, 3 and 6 itself. Then you have to make a set such that all the numbers in this set are pairwise co-prime, which means that if you take out this set 1, 2, 3, then any two numbers won't divide each other, which means that the common factor between any two numbers is 1, which means that only 1 divides both of these numbers. If you take any two numbers as a pair, then only 1 will divide them. There is not a common factor between these two numbers. If I take 3 and 6, then as you can see, if I take a subset 3 and 6, then 3 will divide both of these numbers, which is not equal to 1. But if I take a subset 1 and 2, then 1 will only divide 1 and 2. So you have to make a subset such that if you take any two pairs in this set, then the common factor between them is only 1, which means that they are all pairwise co-prime. Okay, so now the first intuition which come to my mind is, okay, we have to first find out GCD for sure, because GCD will tell us the maximum factor which will divide both of these numbers. Then I can easily find out the factors of that GCD, which will tell us what are the factors of both of them number, because we have to find out the factors of both of these numbers which can divide both of these numbers, and then we have to find out a set from those factors. So first find out the GCD, then the factors of the GCD, which is 1, 2, 3. Then the main task is how to make a subset of these factors such that it is pairwise co-prime. Okay, so now how you can do this, because let's assume that you have some more numbers. Let's assume 8 is also a factor of this. Let's assume there is some other number. Then it is always beneficial to take out only the prime numbers, because if you just take out the prime numbers, then the prime number is not divisible by any other big number, because as you can 6 is divisible by both of these numbers, 8 is divisible by this number. So if you take other number with numbers other than prime numbers, then they will always be divisible by this number, because if you take a subset of them, then they will always get divisible by them. So it is always beneficial to just find out the prime factors of this number. So this is the next observation. What you can see, you just find out the factors of 6, or else you just have to find out the prime factors of the GCD of both of these numbers. So that's the simplest explanation for this. So how you can find out the prime factor? If you know how to find out the factors of any number, then you can just modify the code a little bit to find out the prime factors of that number. So I will take down to the code part now. So what you can easily do here is, let's assume that how you can find out the factors of any number. Let's assume you want to find out the factors of 6. So you will iterate over under root from I equal to 2 till I equal to less than equal to under root of 6, and then for every I you will check that, okay, if this I divides this 6, then the factors is I and n divided by I. Okay, so that's a like a topic for another video, but that's the simplest explanation to find out the factors of a number. Okay, so I'll take on to the code part now. So this is the simplest code in which, okay, remove this part. So what you'll do, take the input of a and b and also the input of those numbers, then find out or compute the GCD of both of the numbers. This is a predefined function GCD in C++ to find out the GCD of any two numbers, because numbers are pretty large. As you can see, they are 10 to the power 12, I think so. Yep, so I use this long. Then after finding out the factors, I will use a vector to store out the factors of this number. So we have to find out the prime factors. So how you can find out the prime factor? We'll iterate over from 2 till under root of this GCD. You can iterate over from 1 or 2 till under root of GCD, or you can also do, if you take out this under root from right hand side to the left hand side, it is like I into I less than equal to like comp. So it is like simpler and I plus plus. Then what you'll do, I'll tell you more with some example. So if you find out that you have some number, let's assume equal to 12, then you find out that 2 is a factor of 12. Let's assume you are iterating over from left to right. You take 2 as the first number, you find out that 2 is a factor of 12. Then what you will do, you will know that 2 is a factor which is the smallest, so it means it is a prime factor. Now you will keep on dividing 12 with 2 such that there is no other factor remaining 2, because we don't want some another number which has a factor 2, because 2 is the smallest number, it should be a prime factor. So we will keep on dividing 12, then we will make it 6, then we will make it 3. Now 3 is the smallest number again which doesn't have any factor as 2, and we will ensure that okay, now we have counted 2 as a prime factor. Now we will find out the factors for 3, because now our number has reduced down to this number. So that's how you can find out the prime factor. You just reduce down this number to a smaller number such that you will reduce down all the factors you have taken initially from the original numbers, because you don't want that factor to occur again in that number. Okay, so now if I find out that my GCD is divisible by I, then I will push back that number in the factors array, and also I will keep on dividing this comp with I. Whenever it is still divisible by I will keep on dividing it by I. Now my final answer is, let's assume that I have one case which is missed, because 1 is also a number I have to take, because 1 is always a factor I want to count in. Because as you can see, 1 is a factor I always want to count it. If 2 and 3 is a pair, then I can always put 1 at the start, because the GCD of this is always 1. The GCD of pairwise is always 1. Also the second case is, let's assume I have a number equal to 3 or like 6. Then I will check that till under root of 6. Okay, my I is equal to 2 in the start, and then I will check that for I equal to 2. This is less than equal to 6, under root of 6, okay fine. Then I will push back 2 as a prime factor of 6, and then I will divide 6 with 2, it will turn out to be 3. But as you can see, now my I is equal to 3 in the next point, because my I has incremented. But now my I has incremented and my comp has decremented. As you can see, my comp is decremented to 3. And now my comp is equal to 3 and my I equal to 3, so it's I into I less than equal to 3. So it's 3 into 3, because my I is equal to 3 at this point, less than equal to 3, no. So I will not count this 3, but my factor is 2 and 3 for 6. My prime factor for 6 is 2 and 3, but I have not counted 3. Why? Because I have decremented my count, my comp value which is calculated, and also I am incremented my I. So in the end, I have to also check that if my comp is not equal to 1, because let's assume that my comp is equal to 4, my GCD is equal to 4, and I have taken 2 as the first prime factor. I will find out the 2 is the first prime factor, I will take this sound 2, and then I will keep on dividing 4, then it will come 2, then it will become 1, and then this loop will break out, which tells us that my number is decremented till 1 at the smallest possible case. If my number is not decremental till 1, then I have to also increment 1, which means that there is some more factor remaining at the comp which I have not calculated earlier in this loop, but I have to add it also. So I can add like this plus plus when my comp is not equal to 1. So I have to find out the total number of factors which will store in total. If I also check that if the factors I have calculated are prime factors stored in this, if the final value of this comp after of all this calculation is not equal to 1, I will also increment this total. And in the end, I have also told that I have not calculated 1 as the answer because I have to also add 1 in this total set. So I have to also increment 1 in the end because the total size will also be 1 plus the total answer. And that's the simplest explanation for the fourth problem. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.